Hello people, it's David here and I'm back with another of these breakdowns. Before I begin, I want to apologize in advance. It's getting a little warm here in Stockholm, summer is coming, and my apartment, for one, is pretty hot, so I have to keep windows open and a few fans running so that me and my computer don't melt away. So in case you are bothered by the background noise, apologies in advance, and please let me know on a scale from 1 to 10 how annoying it is. I try to keep things on low, but trying to survive here. The task for today, it's going to be a pretty quick tip, you can say. We're not going to do like a full project from start to finish. I just wanted to talk about this sim here. We have, first of all, the sideways emission. Instead of a pool alongside the floor, I just put the emission object up top like this. So if the wireframe is now my domain and the solid object is now my emitter. So you can see that it's just going to emit on the side there, and then gravity is going to do its thing and it's going to crash down. But we spent a lot of time talking about Hybrido already in the B session, so if you want to get into Hybrido, check those videos out. And I'm not going to talk about the liquid sim part very much today, only the parts that relate to the fact that the liquid is pushing the object over. So we're going to talk a bit about object dynamics and which buttons to push in order to get that up and running. There's also a new addition here, which is secondary emission. We see a bit of foam going on, but I want to save that for later tutorials. We're probably going to look at splash emitter in the upcoming E video. So object dynamics. There is a rigid body in here, and it's being pushed by the liquid. It could float actually on top of the liquid if I were playing a bit with the density of the liquid and the mass of the object. But what we're going to do is look at how to set it up and how to get it to interact. So without further ado, let's cook something up. If we ignore all of this for now, I'm going to take the domain and turn off read-write on it. And I'm just going to hide the container, and I can keep my daemons active at least. So I see... Well, I don't need to see them actually. Let's turn everything off. Let's bring a few objects in. So this is going to be a few rigid bodies, if you will. Active rigid bodies. Rigid bodies is, back in the day, before Maya had encloth or anything like that, there was only a pretty shitty rigid body implementation, which was, fast enough if you had a few objects, but it was really cumbersome to work with. The caching was pretty bad. It would glitch and mess things up for you. And obviously now we have things like encloth. We can do collisions in there, and we have Bullet, as many other CG apps do as well, which are really fast. And even though they're kind of a cheat, they really are pretty stable as well. But before all of that came along, Realflow had its object solvers, namely Curante, which is the solver name. You can find it under options, and you have options for Curante. Curante is really rigid, no pun intended. It's a really stable solver and pretty trustworthy. So back in the day, when I started using Realflow, you would see a lot of people using Realflow for its object dynamic capabilities as well. So what I want to do is take all of these, and I want to make them into, first of all, I'm going to group them by Control G. You can also right click in the noded list, so group. And the reason I want to group them is because then I can do just one connection instead of connecting each and every one to gravity, for example. So now I have them both connected to gravity, and I can select everything inside of the group by clicking here, select members, and then I want to set the dynamics to active rigid body. So dynamics setting, which is for every object. If you look under my Hybrido domain group, you can see that the container itself, for example, has dynamics. So even if you would think that, oh, we're simulating a liquid, so it has dynamics. Now in Realflow, the dynamics property is just for object dynamics. We see simulation active. That's another entirely different. So we have connected them to gravity, and I just want to make sure I'm not doing command line anymore. I want to reset, and we should see these starting to fall down now. In this early stage, I'm just going to go into options and put my settings way down low to 50, which is just a draft setting, which is going to make this move a little faster. Karate is not as fast as Solver Ran maybe, but it's still pretty darn capable, and I think the wait is usually worth it. But what's going on here? They're starting to fall into infinity, and that's because we don't have a collider yet for them to collide with. So let's bring in a plane, and let's make that plane, first of all, another color so we can distinguish things in here. And this time I'm going to set it dynamics to passive rigid body. And then we're going to connect it to the group. We don't need any gravity or anything on the passive rigid body. And now you should see that everything is starting to collide, but the objects aren't colliding with each other. And why is that? Well, if you recall, we only connected the group, which is kind of the equivalent of connecting, you know, let me ungroup here. So grouping is the equivalent of doing this, connecting each and every object to the passive collider and to the force. But in order for them to actually act on each other, we obviously have to connect each and every object to each other. And this honestly becomes a bit tedious, don't you think? So in this case, it definitely makes sense to, I mean, like I said in the crash course, if you want to use hubs, that's perfectly fine. I tend to not use hubs so much because I want full control and I want to control what is being connected to what. But when it comes to object dynamics, I definitely recommend using hubs, because then you can do this instead. Then you can just create a hub. Okay, you don't even need to type because it's on the way bottom here, a new hub. And then I'm just going to connect the plane to the hub and the sphere to the hub, and everything that's connected with the hub is going to interact with everything else that's connected to the hub. So now we don't need to be concerned anymore about that. And I have not reset properly. I think I did some stupid mistake in the midst of it all. Unplugging and replugging in the mid. I should have gone to the first frame before changing the setup. So now that we've connected everything to the hub, we can sim again and see if our objects will act on each other. I'm just going to switch things up a bit when it comes to the coloring. So far so good. So let's see, what can we do in terms. So I just had a bit of a crash because I was scrubbing like crazy on the timeline, and obviously I didn't save, so let's just set up another example. Let's first of all check out the object dynamics shelf, which is good to be aware of. We have active rigid body, passive rigid body, pretty much the same stuff that we interacted with through the dynamics property. I just wanted to show you that if I create a plane and go to object dynamics and set a passive rigid body, see what happens here. It just makes that setting for us. That's pretty much all it does. But sometimes it's nice to have multiple ways of doing things. So we could select all of these and go to object dynamics and active rigid body. So far so good. And if we connect all of this to a hub and connect it, they would fall down in the same way that it just did. Another thing to be aware of is multibody. Multibody is a way of importing multiple it could be alembics, it could be scene data files, and get them into one single object collider. And it's good to know, I don't have an object prepared, but what I can do instead is create a word, and by default a text object will put everything into a multibody. So instead, as a demonstration, I'm going to use that, and I'm going to go to Object Dynamics and set an active rigid body, and I will collide the text with the plane, and I will use gravity on the text. So I'm just going to let it sim as the ambulance outside passes. So you can see that gravity is acting on the text, but also each letter is being collided individually. And that's really important because you don't want it to be like a whole chunk that is magically floating into the air, even though they're not physically connected with each other. So active rigid body works on a multibody as well. And then there's a whole bunch of other things like joints and fractures and servos, but we're going to get to that at a later stage. This is just the first pass at this. But another thing that's interesting, obviously, is having these rigid bodies collide with the liquid. So let's set that up. And what we need to do for that to work is just collide the text with the domain as well. And I also want to collide it with the container, because otherwise, if they reach the end of the domain, the liquid is going to stay in there, but the letters are just going to pass magically through the wall. So I want to be colliding with the closed container as well. And if I go to the closed container, I see that dynamics is not enabled, so I need to set it to a passive rigid body. And as soon as I enable that, I get a rollout here on the rigid body. We've already set it to solid outside for as far as liquid sim is concerned, but we need to also set that on the rigid body, because the rigid body is looking at the object a little differently. So we need to set the collision side to inside in this case, because that's the negative normal. It's really colliding with the inside here. And then we have things like object friction. So if something should be able to slide for a long way on the surface or not. And we also have elasticity, which is pretty much just bounciness in a fancier word. So let's put down, I don't want it to jump around too much in there. And we could get rid of that plane now because it inhabits the same area as the bottom. And I will just scale it down, brute force, and get this thing ready to sim. So turn back my domain. So that's going to sim now. Let's just see what cell size I have here, 0.15. A little rough, so, but I don't want to wait too long for this. Normals on texts are horrible, so definitely want to use hard shading on that. And let's just make it a pretty color, or a not pretty color, but whatever. And you know what? Let's have the plane there not being a collider, but just for visibility, so that we see it. So we see like a ground plane, because I don't want to use the grid. So no grid and no domain, but collisions galore and drag force. Could plug the drag force to the text as well. And we're ready to go. So with the default settings, if this was a perfectly stacked set of cubes, with the default settings, I mean, the letters are uneven, so they would have collapsed anyway without the interaction of a liquid. But the cubes, if I would have set up, 3 cubes on top of each other, for example, they would have been sitting on top of each other and settled, and it would have been a nice little tower that would have been standing there, because the default settings are pretty like heavy objects. So maybe the liquid would have toppled them over, and if it didn't, then I would have to come down into the object, and on the rigid body you can set the density of the entire object, and then on the domain you can also set the density for the liquid itself. It's important to distinguish also that if you do not use a multi-body, then it's not called density, then it's called mass. And that's because you cannot set individual individual values for the letters. They're all clumped or kind of combined. So here I could say that the cube weighs 1,000, is it kilos? Pretty heavy cube. Yep, object's mass in kilograms. But if you put density instead, then it's going to calculate the volume and then apply density to that to arrive at, you know, what the weight of the object is. And the default setting, if you just go to command line, the default setting for verbosity is going to actually show you the weight, the final weight of each letter. If you actually wanted the object to sink down, or if you wanted them to be lighter, you can just experiment with the density value, and then you can restart the sim, and you'll see in here kind of what mass it's going to assume. So obviously an object that weighs, an object that inhabits a volume of 0.05 cubic meters is not going to be, and weighing 58 kilos, it's not going to be terribly light, so it's not going to be carried around forever. But where the liquid is really strong, where the current is strong, then it will definitely be carried around. So let's just play back. You can see how it's kind of, see some of the letters are being sunk into the ground. Why am I not seeing my particles? Oh yeah, remember how I turned off? Great. I turned off the simulation for the closed domain, so now let's turn that back on. So I did calculate, and that carried through to the object dynamics, and those were cached, so they now have an animation. But that's the same thing did not happen for the liquid domain. So it was still being simulated, but at the end of each frame, the data was just scrapped, and it kept going to the next frame without saving anything to disk. So the only addition in sim time is here is going to be the time it takes to actually write the particle cache to disk. So it's really just a balancing act between the density of the liquid and the mass of the object, or if you're using multibody, the density of the multibody. And then there are things you can do in terms of, like, it tends to be a bit of an experimental thing. If you have an object like this, if you saw the little teaser that I put out on Instagram, let me bring it up real quick. Honestly, there's a lot of issues in this one, which is why I made this little focus glitch, because I just wanted to render it out. But one of the letters just ridiculously kind of spluttered around, and then the letter Y there, it's actually not in focus, but you can really see that it's jerking around quite a bit. And you will see the letter U is flying off the face of the planet and bouncing around there, and it's creating quite intense splashes. And this scene, if I wouldn't have told you, you probably wouldn't have noticed. And it is a chaotic scene anyway, so it's not a huge deal. But what I didn't do is I did not go into options, and I didn't put this very high. I probably should have put this a lot higher. Like the quality, when it's time for final res, I usually leave this at 100. It takes it could take a few seconds more, or a minute in total per frame to do the object dynamics, but it's worth it in the end to have really stable objects. You don't want them to be jerking around. And if you want kind of like micro movements to die out faster, like once it's settled on the ground, you don't want it to kick up any energy anymore, you can just start lowering this. That's what the jittering attribute is for. And then it comes down really to like the elasticity and friction properties on the object that you have. So you want to, for example, make the text object less bouncy, more friction, and you can do the same on the domain container if you want to. The rigid body settings there. There we go. So you can play with these as well, these individual settings, and then it comes down to really just trial and erroring a density that works well with the relationship between the fluid and the object. And you don't want it to be like, we haven't done that yet, but you can do stream emission. This is going to work, by the way, with diverse zones, tandem particles, whatever. And if you're streaming, if you're really just emitting like a hose of water, then you don't want to put too high speeds on there, because that was like the first thing I did, which caused me huge issues. I was pushing out the liquid at a velocity of 10 or something, and usually if you go above that value, you kind of start to introduce bit of a bit of instabilities, and unless you're doing higher substeps. So don't emit too fast, and check your substeps both for the liquid, obviously, and for the quality of the Currente. But you see here what we have. I mean, this is pretty darn nice, actually. It's pretty cool. And the further that this runs, the liquid is going to dissipate, and then those objects aren't going to float anymore. So that's I mean, that's pretty cool. Last but not least, instead of doing rigid, you can also do soft. So let me get rid of everything except for the plane, and this time I want to use the plane as a passive body. And now let's do a bunch of tori. If that's not the correct plural, I would have sounded like a complete douche. Toruses or tori, who knows. And I want to put it like this, and we can do then object dynamics and soft body. And let's go to plane, and let's do gravity and drag force, and let's take the torus, push it up a bit, and let's drop it at a 90-degree angle. And now I don't want command line anymore. I want to see this in real time, or as fast as I can at least. And you're going to see that the default settings are going to be like semi-stiff, kind of squishy bit of object. If you go down to the settings for this, you see that there's way more attributes now to be playing around with, but this has been around for as long as Realflow has been around, really. So there's pretty good documentation. So I would just check out each one of these with the F1, or read the help section on the soft rigid body, really. It's pretty self-explanatory, most of it, and usually default settings are alright, but you can go in and you can kind of figure that out and trial and error your way to success. There is a way to use, like, this is a pretty low res torus, and I could bring in, say I have a high res donut with sprinkles and frosting on. I could bring that in as a high res object and let the deformations of the low res object drive the high res object. And a quick tip, by the way, not really related to this: if you think that an object has too low resolution, I mean, obviously you could bring this in from your 3D app, but if you wanted to create a torus inside of Realflow, you have to do that with scripting that has higher settings. But the good news is you can save a script to a shelf icon. I just want to show you real quick. So if you go to layout, there is batch script, and I'm just going to type scene dot add tor, and you see that it recognize what I was trying to do, so I press enter, because then I get the right amount of arguments. And 10 would be the divisions in U, and 20 would be the divisions in V. So let's say I want 16 and 32 instead, and I just go to script and run. So you see that I now have a much more higher res torus. So let me use that one instead, or let's see, we can go down to high-res object and select our torus 3, and now go back. So you see that simulation is being carried out on the low-res object, but it's also deforming the high-res object. How cool is that? And obviously, I mean, you can collide soft bodies with rigid bodies, and you can collide both of them in a heavenly mess with any type of liquid that you want. So that was, you know, a bit of love for a feature that's been around forever, and a pretty cool feature, and a pretty powerful feature. There is also an addition to object dynamics recently, which is the particle skinner daemon that you can use in Diverso in order to kind of make every vertex into a particle and do object dynamics that way. I'm not going to go into that today. Let's do that in another chapter, but it has its advantages. So any of the stuff that you've seen maybe from the last release of Realflow, where they dropping like a whole box full of some, like the Stanford bunny or the Stanford armadillo or whatever it's called, that I think those are all done with the Diverso object dynamics. But don't quote me on it. Let's see how to set it up with Diverso as well, just as a rounding things off kind of thing. I have a round emitter. Let's see if the default density is going to be enough to actually do something. I can use this button here to swap between global and local transform. And I want to swing it over there and without losing my downward angle. And now you obviously see that I would need to start to counteract the weight of the object with the density of the fluid. Set it to 500 and let's start with just lowering the density of the object or the mass of the object and start going command line, and I want to use Diverso CUDA. Speed things up. Because it really does speed things up, if I haven't mentioned that already. At frame 40 now, so I'm not really seeing too much. So let's crank just to see some effect. Let's take this up in size. Let's actually emit like so it hits the top there. And I want to bring up the speed to, let's say 4. So also do a bit of randomness to get rid of some of the sheeting effect here. And sim again. I did not raise the density or the I didn't lower the mass of the torus at all yet. But the speed should do something. The speed of the liquid should do something, but it's not. It's not doing anything. I think I see a bit of like reaction in the object surface. I think it might actually be indenting it ever so slightly. Look from the side. Yeah, I mean, yeah, it's actually acting after a while. It's starting to win it over. So now let's bring it down even more. If this was supposed to be some kind of like a bath toy, then a massive, I mean, I'm way off scale here. You can always go into tools and you can do measure, and you can see that this is a the volume of this is 4,778 liters. So it's way huge, actually. So I would have needed to check my scales if this was proper. So maybe it should be 50 kilos. Did I even start a new sim, by the way? This heat is impacting my cognitive abilities. I start forgetting things and not remembering where I was. But now we definitely have an effect, you see. That's cool. Cool. I don't want to do any more than 100, so to just round things off, let me just raise the domain ridiculously much in resolution, and let me also introduce a bit of friction for the Diverso liquid on the ground plane, because that's one of the most ridiculous things. Giveaways that is liquid sim is that it does not have friction, it just slides around. Default friction of any surface, your floor in the living room or your kitchen top or your kitchen table should typically be way higher than the default. It should also be textured, to be honest. If you have wood fibers going against the grain, that should affect the way it's flowing around. But let's look into texturing object properties in another tutorial. So I'm now running again. I have way more particles, so it should be a little more fun to watch. And we're already at frame 37. See how much nicer that is? Much more believable thing than this brain pattern that I was getting before. I need some cohesion. And if you think that you want some of those details back, definitely you should have in this case, but those you can achieve with surface tension instead. So I wouldn't be too concerned about that. And you can set surface tension on the domain itself for Diverso. And you can also set it with the daemon, so either the surface tension daemon or the new macro daemon, by all means, which is going to give you sweet details. So what happened now is I raised the particle count 50 times without raising the density, and I would probably have to raise the density a bit because it kind of, the calculation is going to figure out like the weight of each particle. So the more particles, the lighter each particle gets, and it's not really toppling it over anymore. So I don't need to raise the density of the particles 50 times, but I can raise them at least 10 times, and let's see if that is enough. So it's good that you got to see that actually, because that's one of the parameters you have to be aware of and kind of balance back and forth. I should already see a result, frame 17. Yeah, you can see that this time it's going to work. It's already starting to kick over in that direction. I don't really know what object I'm thinking that this should represent. It's definitely not like a bath, a tube that you use when you're swimming, because that would have been way lighter. If we opened this, looks like a proper sewer drain, so it definitely would have been way lighter. So, I mean, we don't need to be that precise in this matter. You can actually make double sure that the command line tool actually resets the scene before it starts to sim. Usually with liquids you don't have to do that, but now that we're using object dynamics, let's just put that just to be on the safe side. Yeah. So now it's definitely having an easier time pushing it away. That's fun. And then we could be playing with, the friction that it gets and everything. But I'm just going to call it on this. So I hope you had fun. Object dynamics, it's really not that big of a deal. It's just something for you to use in order to get those animations if you want to. I mean, a lot of times when it comes to these type of scenarios, you will get an already finished animation from an animator if you're working in production. So then your job will be more of kind of like matching the surface and everything and making sure that everything works there. But if it's the case that you're kind of scattering debris or something like that, then you could by all means request to just have a layout with things roughly where they should go, and then you could take a pass at doing object dynamics and delivering back an SD cache or importing that SD cache and then writing out an Alembic. Or you can also export objects as Alembic straight from Realflow. So, object dynamics in Realflow. By all means, try it out and have fun. I can't believe how close I came to forgetting to tell you about initial velocity. Of course, it would be the most boring thing in the world if this is just going to drop down like this and nothing more is going to happen than that. Obviously, this needs to be set to inside. Boring. But in order to kind of make things happen in your scene, as you may have seen like in some of my early videos, like the cross is one, for example, you see the cross is flying down, it's tumbling around. You want some kind of initial velocity, and that can be found on the rigid body. You have velocity. So velocity is measured in kind of like units per second, or meters per second, because one unit is 1 meter. So if I wanted this to fly over in this direction, you have to think about this in world transform values. So the x-axis goes in this direction, and z goes in this direction, and y goes up, of course. So if I wanted this to fly into, for example, over to the other side here, we will need to give it some positive x. We can see that by looking at the compass down there. So I'll give it a speed of 5 meters per second. That's what 5 meters per second gets you. If I also wanted to fly in an upwards arc, I can give it some speed in the Y direction. So I give it 10 in Y and 5 in X. If I wanted it to fly into the upper left corner from this view, what do you think I need to do? Can I give it a Z? If I give it Z positive, it's going to end up in this direction. So I need to give it Z negative -5 as well. And now we're missing the exit. Or we're missing the corner, rather. So -2. That's better. And to make this a little more lively, let's also start introducing velocity in the rotation. So if we look at global rotation values, we see that X is going in this direction, and that seems like something I would want. So 45 degrees per second. Let's try that. That's cool, but we want more. Let's try 180. Now we're talking. Boom. Cool. And now we can start to give it some elasticity, maybe. Look more funny if it's bouncing around a bit. Boom. And then it would probably be a fun thing to start duplicating this. When you duplicate, the new duplicates also get the same connections. That facilitates things. So now I only need to make sure that they have connections between themselves. Maybe switch things up a bit. And you can then start to vary the mass. So this one is heavier than the other two, and that's gonna kind of give it the upper hand in terms of collisions. So it's not going to be pushed away too much. Now we're starting to have some fun. Obviously, this is way too thin to get some kind of like believable collisions. So if I actually wanted to interact with the edge of a pool or something like that, I would model that up with cubes instead. So I would do that in my CG app, or just put cubes on the edges, and so I have some kind of volume to collide with. But we can fix that by just shuffling things around here. And if we make this one soft instead, for example, you see that it still has velocity. So you can use that pretty much the same way. Let's try it with a multi-body as well. Let's show you another way of doing multi-bodies is, or to get more objects, pretty much, is if I go to tools, there's something called create array. And create array is going to allow you to create circular or rectangular arrays. So kind of like a grid of objects, which looks like this. So now we have 2 by 2 by 2, and we can also create circular. So that would put them in a circular fashion like that. Maybe let's do circular. First of all, I want to put it on edge, and then we'll do circular, and let's see, that looks better. And I will do distance 2 by 2 by 2 maybe. A little more. 3 by 3 by 3 is gonna be too much actually, but anyway. So now you see we got a new object called a torus array. And I can just move that up and tell this to be an active rigid body, and just like with the letters, it's now going to respect this as individual objects. Of course, we need to connect them to something. So they're falling down now, but we also have to give them the same velocity, obviously. So 5 and 8 and 50, or at 180, 45. Just give them some kind of velocity in every rotation angle. The downside of this, of course, is that all of them are going to have exactly the same one, because just like with the density, you can't give individual values to individual objects in the array. But what I could do is I can just mix things up a bit. I could throw maybe another object in there that collides with them, or something like that. So this approach would be your friend, like if you wanted to create a tower of something. Let's zero this out and put it over here. And I'll go into create an array again. And this time I'll do rectangular, and I won't do any X and Y items. I will only do X and Z. I will only do Y. So if you push the 1, it will just be this. It will be one object, pretty much. So there we have a stack of tori. And we could do, for example, if we set it to 2.5 and we rotate it first, and then I rotate it the other way around and take the second array, move it out, so now they're kind of set up for disaster here. It's going to topple on top of each other. It's going to be fun. So I'll just delete the original torus and set everything to object dynamics. And so how sweet is that? You can create a whole bunch of things falling down. So there we go. It's pretty cool. Pretty awesome, I have to say. Easy way of creating multiple, like a stack of coins or poker chips or whatever you will, or dice or Fruit Loops. So if you were thinking to yourself, can I make a soft body and can I use a soft body on a multi-body and make it collide individually? The answer lies here. Yes, you can. Allow me to make things a little more interesting. So here we go. A little more fun scene to look at is now done. So we can just play it back in the viewport. Boing. I made it pretty, it's pretty just default settings. It's just a really low density. So they're really squiggly. You could be playing around with the settings if you did not want that. Could be fun also to drop a heavy thing on top of everything here. Now we can finally wrap things up. And as always, I would love to see what you can come up with any of the techniques that I've showed you in the Liquid ABC videos. So feel free to hashtag Davesplaining or mention at Davesplaining on any social media you're at, or at least Facebook, Twitter, Instagram. We would all love to see it, and we would be happy to spread the word of your work, regardless if it's personal or professional. And as always, please support us. Please like this video, share the word if you liked it, if you have a friend that maybe would like to learn about Liquid Sims. And if you don't like it, let us know in the comments below what we could improve. And that's really it. So I'll see you around in the next tutorial. Have a great day.